trickling in.
Perfect.
So we're very happy to have Camilo Acosta presenting his work on the quality of communications infrastructure. And I'm just gonna, we have, sorry, we have about 60 minutes for the presentation. We'll leave the last 15 minutes for questions and discussions. And just to note that this is being recorded and will be on the, I think it'll be on the AREUEA website. So thanks so much. Take it away, Camilo.
Thank you, Tess, and thank you, David, for hosting me. It's good to be here. This is joint work with Luis Baldomero Quintana, who is also here in the main table. He will be in the chat, like answering some small clarification question in case there are any. But feel free to also interrupt me if I can reply to anything. So this is basically a paper of how better internet affects local economies. So it's a very fancy and long title, but it can be summarized in 6 words, right? How better internet affects local economies. And I think we cannot deny that internet is important, right? Like, if it wasn't for internet, we wouldn't be here sitting like, I don't like doing this presentation, but also like having this fantastic AREUEA series. And for example, also the negative effects of the pandemic, there is some preliminary evidence showing that the pandemic would have been way worse if it wasn't for the good quality of communication infrastructure. So in general, internet is a good thing, it's important. And communication infrastructure in general differs from other types of physical infrastructure like trains or roads in at least 3 aspects. First, good communication infrastructure reduces communication costs between a location and any place in the world, and not only with neighboring locations. So for example, if we build a road between Medellin and Bogota, yes, it reduces the transport cost to Bogota and then to the rest of the world indirectly. But if we invest in better communication infrastructure and better internet in Medellin, we can communicate easier, directly, and cheaper with the rest of the world. And through this cheaper communication cost, it also increases the quantity and the quality of ideas. And we know from the growth literature, well, first we know the ideas are non-rival, and we know from the growth literature that non-rival goods are usually good for economic growth. So it shouldn't be a surprise that we find that better internet leads to higher economic growth. And finally, better internet also improves the technical functionality of some information and communication technologies. So through better internet, we have been able to use our computers better, our smartphone better, even our refrigerators better, right? So all these Internet of Things, all these new capabilities that we can have with internet. So this is why when we see the literature, there is a ton of research studying how decreases in communication costs have led to more innovation, more entrepreneurship, larger firms, more firm expansion, cheaper houses, more expensive houses, sorry, and more trade flows. And this importance has also been recognized by policymakers throughout the world. So in particular, I would like to point out to this Biden-Harris administration Internet for All initiative that basically approved $65 billion to bring to give internet subsidies for low-income regions across the US to try to bring down the digital gap. But even though this is a paper about the US, we feel like the conclusion will be applicable to every other country. These type of policies are in place in Colombia, in Brazil, in the UK, in Canada, and so on. So what is our question? Our question is, what is the causal impact of a higher quality of communication infrastructure on local economic activity? And by local economic activity, we're going to be focusing on 2 main outcomes. First, economic growth, either both short-term and long-term, and also structural transformation. That change in the sectoral composition of local economies. And to study this question, we're going to use cross-sectional county-level data for the US, mainly 2018, but also for other years. And we're going to combine it with some historical data for the earliest stages of the internet. So in particular, our identification strategy is going to rely on instrumenting the quality of internet using the connection between ARPANET nodes. So what is this ARPANET? So ARPANET is a network which was the precursor of modern internet. It was created around the late 60s, early 70s, and for defense and academic purposes. I'm gonna tell you a little bit more about the history of ARPANET in a little bit. And this ARPANET was later became part of the national backbone of the internet. So I always like to give like the example of, imagine you have the whole body, you have the main circulatory system with the main veins and arteries. That's the main backbone of your circulatory system, right? And this is like the internet. So ARPANET was built as a small network, which then became part of a larger network, that then throughout small vessels, top tier 2 and tier 3 and networks, brings internet down to local economies and local neighborhoods. And we're going to argue that our instrument is valid, exogenous, and satisfies the exclusion restrictions. Here is just a summary of those arguments. I'm going to argue more later on, but first, instrument is valid since counties closer to these ARPANET connection lines have better internet today. So even though this was a network from the 1970s, this still has an impact on internet today. Second, our instrument is arguably exogenous. So we're going to try to argue from historical evidence that the location of ARPANET nodes was exclusively influenced by military and academic interest. But moreover, we're not going to use those nodes. We're going to use the connection between those nodes. So we're going to ignore all the places that had some nodes and focus on the connection lines. So for example, if we see that there is some connection line between Colorado and St. Louis, Missouri, well, that line is going to cross a lot of counties in the US, and probably the productivity of those counties today is going to be unrelated to the fact that someone choose to have ARPANET nodes in St. Louis, Missouri, or in Denver, Colorado in the 1970s. And we're also going to argue that our instrument satisfies the exclusion restriction, and that lines connecting ARPANET nodes can only impact local economic activity today through current internet, and that they are uncorrelated with other types of infrastructure. So just to give you a preview of our instrument. So in this map, we show first that average download speeds in 2018. I'm going to be clear about the source of the data in a minute. Darker blue colors show faster average speeds. Shining yellow show slower speeds, right? We also show in this map the ARPANET structure of 1979. These blue dots show the nodes in 1979, and these red lines show the connection between these nodes in 1979. So I think from this map we can have two conclusions. First, that my co-author graduated from Michigan, and he shows the colors of this map. But second, that it's clear that the places closer to these red lines are places that tend to be surrounded by these darker blue colors. This means that places that are closer to these connection lines in 1979 today have faster internet speeds. And places that tend to be farther away from these lines tend to be more yellow or tend to have lower internet speeds. Of course, there are exceptions like Washington, Minnesota here. And so we're going to try to formalize this visual evidence into our empirical network, combining this historical data with a lot of controls that account for border effects, for market access, for geography, to try to pin down what is the causal effect of internet today. And in a nutshell, we have three main results. First, that faster internet in a county, it's a county, not country, leads to higher short and long run growth. So it's not only beneficial for like 4-year growth rates, but also for 10, 20-year growth rates. It also leads to a local structural transformation. It means that it's shifting the structure of economic activity from a base of local non-tradable services to more high-skilled services sector. All these concerning information services, managerial services, professional services. But it also has some unintended consequences, which is a rising local earnings inequality. We explore some mechanisms. I'm not gonna talk a lot about this right now because then I might run out of time, but basically we explore two mechanisms: input-output linkages and sorting of high-skilled workers. There is also some evidence that there has been a productivity boost in some sectors, and I'm gonna talk more about these mechanisms as we move forward. In terms of the literature, there is a ton of evidence, not only showing how infrastructure affects local economies, but also showing the effects in general of information and communication technologies on cities and in firms and households. We think we have two main contributions to the literature. First, we provide causal empirical evidence that the quality of infrastructure, of communication infrastructure, impacts local specialization and growth. So there is a ton of evidence showing that the quality of physical infrastructure impacts these outcomes, like papers by Cosar and co-authors, Gilles Duranton and co-authors, Gertrude Gonzalez Navarro and co-authors, and so on. But there is very little evidence, at least we couldn't find any important evidence showing that the quality of communication infrastructure impacts these outcomes. We actually were very surprised. Like when we started this project, we thought we find this nice setting, we find the nice data. We thought that with a quick Google Scholar search, we were going to discard this project and move forward with our lives. But in fact, we realized that there is a big hole in the literature studying this quality of communication infrastructure. So we think we're trying to fill this gap. Moreover, we also contribute to the literature studying the effects of ICT. This literature has focused mostly on the question about access, right? How access into internet or how having broadband access affects firm structure, affects housing prices, affect city urbanization, and so on. But there is little literature studying how quality matters. And this is important today because the main difference today, especially in developed countries, are about quality, not about access. So what we see in our data is that virtually all the US all the counties in the US have access to broadband services. But when you see the difference in internet speeds, those are where the gaps rise. So for example, when we compare the counties in the median of the distribution and the counties in the 75% of the distribution, there is around a 300% difference in average download speeds, which is like a huge digital divide. So we're going to exploit this difference. And hopefully when we get published, hopefully soon, we will also publish this map so it can be used by any other researcher. I think there was a question, or I heard some microphone. Okay. So let me start by telling you a little bit of the historical background of the internet and this ARPANET network. So ARPANET stands for Advanced Research Project Agency Network. It was a project financed and developed by the Department of Defense with the objective of creating a network to connect computer centers. So let's think we're in the 1960s, right? We're in the middle of the Cold War. And there were two main issues with the US. First, the USSR has just launched Sputnik, right? So the US was thinking, okay, we're losing our communication race, our space race. We need to invest more money in these issues, in these communication issues. So the Department of Defense had a strong interest in financing this type of research. And second, like communication technology was very primitive. And the DoD wanted to connect computers, especially to lower their administrative costs. So in that moment, they have some basic computers in different Department of Defense military centers. And every computer had their own operating system. Every computer had their own protocols. Every computer had their own, let's say, software. So if you had a technician or someone visiting from different military centers, they had to know all these language programs. They had to know all these protocols. So all these training costs of teaching these techniques about the different protocols, the different programs were huge. And they doubled the budget for software purchases and maintenance. So they have first a political incentive and second also a cost incentive. So they hire a professor called Dr. J.C.R. Licklider. He's considered one of the fathers of the internet. He actually has a very curious background that I haven't seen in any other person. He was both a psychologist and a computer scientist. And he was doing research on something quite esoteric at the time. It was not in the mainstream of computer science. It was called what we know today as network theory. He believed that machines can be used to improve human communication, right? At the time, the mainstream of computer science was we should use machines to improve our problem-solving capabilities, what we call today as batch processing, right? How do we use our computers to process data, to solve some problems? But he proposed that we can also use computers to communicate. Today it sounds normal, but at the time it was not normal. It was some sort of like a secondary field. And this guy, who was there first in the 60s and then in the 70s, he shifted all the Department of Defense computer science research contracts away from private companies to academic researchers. Right? So this was around the 60s, and in the late 60s, they started to create the ARPANET, this network, and they started by connecting 4 nodes, 4 universities: UCLA, UCSB, the Stanford Research Institute, and the University of Utah. Then they realized that there were some good capabilities, like the internet was being useful to communicate about these 4 institutions. So they started to expand the network to other computer science departments, but not to any computer science departments. So there is this book by Janet Abate and other historical evidence suggesting that this computer science department had 3 characteristics. First, that they already had some DoD contractors. Second, that they were doing research on network theory. So as I told you before, most departments focus on batch processing. And so this network theory was like finding a historian of economic thought or a Bayesian econometrician, right? That they exist. They're a valid field of study, but there are very few of them, and they're not in every university. And and also to computer science departments that tend to have a highly collaborative environment, right? Because from the beginning, one of the objectives was to have the technical solutions available to anyone. So they didn't want this private knowledge, they want to have this public knowledge. So as you can see, there is some historical evidence suggesting that commercial interest did not influence ARPANET at all before the 1970s, only military interests. And that's why we see some nodes in small college towns across the US, but also in large cities, right? And we're going to exploit this variation given by the lines connecting these nodes. There is also some evidence that in the late 1980 and the early 1990, ARPANET, well, it started to get slow for what it was needed. It started to become obsolete. So first, the military left ARPANET, leaving only those academic networks. Also, the National Science Foundation started to create some smaller regional university networks in the early 80s. And this was more, they had funding for these networks, but it was they conditioned its funding on universities having to find other commercial clients. So this created these incentives for commercial companies to join the networks, for universities to try to find other partners so they can exploit the economies of scale. So just as a conclusion a comparison between the previous slide and this slide is that if we use the ARPANET network in the 1980s, then we might run into some endogeneity concerns because there might be some correlation between the productivity of these places and the choice of the network, while in the 70s, there seems to be at least no anecdotal historical evidence, no correlation from the historical evidence with these variables. Then in the late 80s, the National Science Foundation and the DARPA, the Defense Department, started to create an interoperability between ARPANET and the National Science Foundation network. And then by the time ARPANET in the early 90s became obsolete, it was decommissioned in the 1990s and transferred its role of network backbone to the NSFNet national backbone, which had more capacity, right? So this is what I was telling you before, that first it was an ARPANET, then they created a National Science Foundation net, then they merged and they created the national backbone of the internet, right? So this ARPANET network now is part of today's backbone of the internet.
Another one clarifying question, if I may. So you're making a difference between the ARPANET network development before 1980 and after, and you're pointing this financing of universities and the requirement that they find commercial clients and like this connection with productivity in the private sector, right? So
yes,
but aren't the universities that were getting connected through ARPANET the same universities that are going to be developing these connections and are better suited to provide these, I guess, like projects with the private sector that involved the internet because they've been using it for 10 years now? at this point in time?
Exactly, but that's why we're not going to use the structure of the network in the 1980s, because we believe it has this type of issues. By the time it was built and it was expanded in the 70s, we believe that these synergies, like these connections, weren't developed enough.
Okay, so the exclusion restriction here would require that basically these universities were getting better at whatever research they were doing through having ARPANET, but that was not spilling over to any type of local economic development.
Yeah, but since we're going to exploit is the distance to these connection lines, not the actual location of the nodes, our exclusion restriction comes from the fact that today internet service providers can provide better internet in those locations that are closer to these lines. So it's actually this won't be a paper about the larger cities in the US. We actually have some robustness checks showing that if we drop this San Francisco, DC, New York, Boston, Los Angeles results hold, it's about the distance to these connection lines that can allow
you don't have to be close
providers.
to the nodes. You get better service by being like incidentally closer to the lines that join the nodes.
Exactly.
All right, thanks.
Thank you, Liz. Yeah, I should be more clear about that. Yes.
Can I ask for maybe more technical details on what these lines are? So like if I'm connecting San Francisco to St. Louis, I dig some giant tunnel or pipe in the ground and I lay some, I guess these days it's optical fiber through that pipe. Back then it was something else. So it's something physical like in the ground that exists. And what is the process for upgrading that? Like, is it easier to like have fast technology or fast connections now because I can just replace whatever cable used to be in the line with something that's faster in the line? And that's why investment back then is good for communication now.
Yeah, so the short answer is yes, but I'm gonna allow Luis to answer this question because you're actually the expert on how this internet service can expand.
The answer is yes. Like when you want to implement, suppose you want to implement fiber optic between those cities because there's no fiber optic in the things that are between two cities. Then you have to build the holes. You have to get the permits. There's something you have to get like the land it's not like a land concession, but it's like a land permit so that a cable can pass through all these lines. So the process to build like new infrastructure to put the fiber optic, if there's no tubes already, it gets really, really complicated because it implies dealing with construction, with land permits, with municipalities, with the state, etc. If there are already holes because they were built because of ARPANET back in the 60s and 70s, then you already did all the permits and all the stuff. So you just have to change the old cable, which was probably like copper. You have to put the new fiber optic, which is the most novel fiber optic today. Yeah.
Okay.
Awesome, thank you.
Okay. So in terms of data, sorry, I don't know why. We're gonna use 6 pieces of data. First, we're gonna use from the county business patterns, the total employment and the total annual payroll by county. With these 2 pieces of information, we can construct average wages by county. In the CBP, they also have available employment and payroll by 2, 3, 4, 5, 6 digit sectors. However, when we start going down this ladder, there are a lot of like confidentiality restrictions, a lot of omission, a lot of beans that are omitted. So we're gonna restrict our analysis to 2 and 3 digit sectors where we actually don't see a lot of these omissions, these confidentiality issues. Second, we also get data, the county level GDP data by 2 digit sector from the Bureau of Economic Analysis, both also for 2018. Sorry, I didn't specify the year. Third, we're going to use from the US Census Bureau the Cattle County populations to study long-term growth. So unfortunately, so these employment, payroll, and GDP data are really good for short-term issues, growth and stuff. But when we start going farther back, there is not a lot of data that can be compared across time and across counties. So we use population. Fourth, we use internet data from the Federal Communication Commissions. So in particular, the FCC has this form 477, which requires every internet service provider in the country twice a year to release all the census blocks that where they are providing services, the technology that they're using to provide services, the maximum speed that they are advertising to consumers, and the maximum speed that they're advertising or they're contracting with firms, right? So it's a huge database. And basically it says, for example, if you have this block where the Department of Economics in the College of William and Mary is located, maybe AT&T goes to that block, they provide fiber optic at a speed of 300 Mbps, so they have to release that specific information, right? So using this data, we build, sorry?
Can I ask you a question here?
Yes, of course.
Yeah, FCC is block data, and the county has hundreds of blocks, and I wonder how do you aggregate into county?
Yes, I was gonna get into that. So first, we focus on the speed offered to businesses, right? So we don't take into account consumers. We're gonna be focusing on business because it's a paper about growth and sectoral composition. Second, we just take the average across all technologies, providers, and census blocks at the county level, both download speed and upload speed. But our results are robust of not choosing maybe the mean, but the median instead. So we do several robustness checks on this regard.
I don't know, here's one key follow-up question. And
yeah.
I guess my issue is that same as my research itself, and you can calculate the speed only if you have access to internet. So a lot of blocks don't have internet access and they are treated as missing, not zero. So I think the speed is an issue because you can have speed only if you have access. If you don't have access, then that's missing and this is highly biased measure of speed.
But most of the blocks at least have one internet service provider. So the good thing about this data is that also satellite providers have to release that information. And virtually in every place in the US, you can get satellite data. So there's actually information about every block in the US. Yes.
I'll let you go, but my point is that speed makes sense only if two blocks have the same access. Otherwise, looking at speed may be misleading because they have different access.
Okay, we're gonna take a look but for now we're gonna use thank you for the comment. We're going to use other controls such as market access, population growth and density, and a lot of geographic controls, elevation, slope, area, weather area, borders, coastline, basically because building this internet infrastructure in places with higher altitude, very steep slopes, close to rivers might be harder. So we're going to take all of that information into account into our empirical specification. And regarding the historical information, we digitized some images of the Commission DoD documents containing these ARPANET maps. So we actually found these physical journals from the 1990, which contain in the Journal of Association of Computing Machinery, which contains the ARPANET completion report and the evolution of ARPANET over time. This article, these images were built by Finn Cerf and Bob Kahn, other two of the fathers of the internet, and they look more or less like this. So the whole US with the nodes across the space and the lines connecting those nodes. So as you can see, this map has two challenges. First, well, we have to digitize the map, but second, we needed to know what each of these acronyms were. So MIT, so we knew what was MIT or UCLA, but once we start going to LLL, LBL, CCA, some of these are agencies that don't exist today, so that we have to do a lot of research. We had two very talented research assistants that helped us with this. And we also were very lucky that So one of these arrays, his dad knew Windsurf, and he put us in touch. We got to chat and we got to write some emails with Windsurf and Bobcat. I think this was one of the most exciting parts of this project, getting to talk with two of the fathers of the internet, and they help us reconstruct all the map, right? So we were missing like a big chunk of the nodes, and they helped us with this, and this is the result from 1979. We digitized the map, and we can see two differences, that there seems to be more nodes here in the West Coast or in the East Coast that we actually can see in the map. But this is just an amplification, so because they are so close together that is not possible to see them from here. But you can also see that not all nodes are connecting between them, right? For instance, this AFWL node is connected to Texas, but not to Collins. You can also see that not all places that traditionally have an important university have a node. So for example, this Texas is in San Antonio, but Texas A&M doesn't have a node. Or there are a lot of universities, good quality universities here in the middle that are also missing a node. Michigan and Arbor doesn't have a node, right? So we're going to exploit the distance between the county centroid to these lines as an instrument for today's quality of internet. And that's going to be our identification strategy. So first, we would like to estimate an equation of this sort, of where in the left-hand side we have an economic outcome of county C. So it can be the 4th-year GDP growth or the 4-year employment growth, or the 20-year population growth, or sectoral employment or GDP shares, as a function of the log internet quality of that county C in 2018. We use several measures. In particular, I'm going to show you results for the mean download speeds, but we also have upload speeds, we have medium speeds, and we have other measures that you can check in the paper. And we have several controls, including the ones I told you before: population growth, density, market access, and different geographic controls. But estimating this equation has a lot of econometric identification issues, because first, it can be that locations that are growing faster today, they already have more productive workers, more productive firms that are demanding better internet, and maybe we have that internet providers are just catering to this better demand, right? So we can have this double causality. We can also have a lot of issues with omitted variables, with amenities and productivity through the error term. So that's why we have the need of this instrumental variable approach, where we estimate a 2-stage model, is instrumenting this log internet quality with some variables concerning ARPANET. In particular, we're going to use the log distance between a county centroid and an ARPANET line in 1979. But I'm going to show you in a minute that this result is also robust of maybe having just a dummy variable if they have a line or not, or distance categories instead of a continuous distance measure, or changing the years of this ARPANET structure. And all our error terms are going to be adjusted for heteroscedasticity and spatial autocorrelation using these Conley standard errors from 1999. So basically, we're going to draw a radius across in each location and take into account the spatial autocorrelation patterns within that radius. So regarding the validity of our instrument, so we believe our instrument is relevant, and I'm going to show you a couple of proofs for this. First, as I told you from the historical evidence, ARPANET predicts today's backbone, and this is very related to the physical infrastructure papers that show that all roads predict current highways. So there are some papers by Duranton, both in the US and in Colombia, showing that it's easier to build highways in places, new highways in places where old roads existed, and this tends to be a good identification strategy for the construction of new roads and the effect of new roads. It turns out that for communication infrastructure is something similar, because as I was telling you before, closeness to this internet backbone allow internet providers to provide cheaper, high-quality internet, as it is easier to construct underground fiber optic. So first, we saw this visual evidence, but second, we have the first stage results.
Hey, Camilo?
Oh, yes?
So you have a question from Betty Wang in the
Yes,
audience?
of course.
Hi, I just have a clarifying question about the timeline, because in the equation that you showed, there's no subscript for time. So I just wonder, like, do you have yeah, so what's the time frame on this?
Yeah, thank you, Betty. I should have been clear about that. So this is a cross-sectional data for 2018. For the growth rates, we're going to use 4-year growth rates between 2014 and 2018. For the 20-year growth rates, we're going to use this decadal population. It's actually 10-year growth rates. So from every 10 years from the 1900 to today, those 10-year intervals, population growth rates, and sectoral shares are just the cross-section of employment shares across sector and counties in 2018.
But your internet quality data is at is in 2018, right? If
the internet quality data is at 2018.
Then actually your dependent variables are actually lagging before 2018. So I just wonder, why don't you put internet quality as the dependent variable? Because then you would have even if everything like about identification is, if that sort of thing is resolved, we also could have a story of these places there's just like a lower fixed cost to improve their internet quality, such that, everything that you have here as the economic outcome can be also explanatory variables for why these places continue to have higher internet quality in 2018.
Yeah,
because it's easier to upgrade, right?
Yeah, so let me clarify one thing. So for the 4-year growth rate, you're right. So we use growth rate from 2014 and 2018 as a function of internet quality in 2014. So we have like the value of internet quality in the first part of the period. For the 20-year growth, our strategy relies on the fact you can think this on like a long-term differences in difference, where the initial value of the internet quality was 0 in the 1990s, and today it's actually positive, right? So there is actually this difference in the 20-year growth rate. Unfortunately, we don't have information on internet quality at this detailed geographic level before 2014. So the FCC started to collect this data in 2014. So I'm afraid this is the best we can do in terms of how we can use the internet quality data. I don't know if I answered the whole, like your whole question, but please let me know.
Thanks.
Okay, thank you, Betty.
Sorry, can I ask a follow-up question here?
Yeah, of course.
Yeah, 2018 is the year when we repeal net neutrality first time, and I don't know, have you thought about that particular year, 2018?
The short question is no, we haven't think about that. Like, we're going to take a look, but the long answer is that results hold if we change the year. So if we don't use 2018 but 2014 instead, or 2016, the results are robust to the year we choose. But at least we should check this network neutrality thing. You're right. Thank you. So in terms of the first stage, we do find that counties that were crossed by an ARPANET line in 1979 have better internet speeds offered to businesses today. So you can see here 2 pieces of evidence. Let's focus on column 2, which already has all the controls. First, counties that were crossed by a line in 1979 have an internet speed today that is 27% larger than counties that were not crossed by a line. These results are already taking out those locations that had an ARPANET node. So this is not San Francisco driving the results, or New York driving the results, or even Denver, Colorado with 1 node driving the results. This is about the lines that are in between. When we include, instead of the dummy variable of has a line, a more continuous measure of the logarithm of distance to the line in 1979, we also find the expected negative coefficient, right? Places farther away from the lines have lower internet speeds today. In particular, places that are 1% farther away from the lines, this is around 20 kilometers, which should be, I don't know how many miles, this should be maybe 16 miles, I guess. It's places that are 16 miles away from the lines tend to have 13% lower internet speeds today. This is download speeds, but the results hold if we include the upload speeds, if we include other measures of ARPANET, such as distance categories instead, as I was telling Professor Lee, like if we include other years of internet quality, such as 2014, or if we use other years of the ARPANET network. So this shows that our instrument is valuable. Yes?
How many counties had a line?
Sorry?
How many counties had a line in 1979?
15% of the counties had a line.
Okay.
So this should be 15, around 400, and between 400 and 500 counties. And this is actually like, so let me highlight, this is actually like, why do we think this is a better instrument than some of the literature has proposed? So there are other papers in the early 2000s that try to use this instrument, but using the location of the nodes. And in fact, only 1% of the counties in the US had nodes, which turns out that they were like a weak instrument, and they end up that they had to look for other notification strategy at the end. But like, it turns out that these connection lines are a better instrument than only those nodes. Second, in terms of exogeneity, is our instrument correlated with omitted variables productivity? So from the historical point of view, we think no, like private companies were not involved in the creation and design of ARPANET. So we should be able to use the whole lines in the whole day, even the nodes in the United States. But when we check the data, we see that there is still some positive correlation between the probability that a location had a node in 1979 and the share of high-skilled services, or business services, or other sectoral measures in the 1970s. So using the nodes, even though the historical evidence is telling us that it's all right to use the nodes, it turns out that there is some strong correlation. That's why we decide to ignore all these nodes and focus on the places that were crossed by a line, right? And once we take out those nodes and run an estimated regression with the probability that a county was crossed by a line as a function of this share of high-skilled services or business services in the 1970s, we see that the correlation is not as strong anymore and even fades in some specification. So that's why, again, we use the lines instead of the nodes. In terms of the exclusion restriction, we don't believe the instrument is directly causing the outcome, right? And we believe the structure of ARPANET exclusively impacts the economic structure of US counties through internet quality today. Basically, what my co-author was telling before, that it's easier to provide better internet in those places that already have some infrastructure in terms of bureaucracy, in terms of cost. It's easier that way. And we have at least some visual evidence that the ARPANET structure is uncorrelated with other types of infrastructure. So let me show you these maps just to show you that it seems that these ARPANET lines are not so strongly correlated with places with the interstate highway system. So there are some places where it looks like they're correlated, some places where they're not, or some places with highway but without lines, which is good for our identification. But we are working right now on bringing this information on railroads and roads into our specification. So right now we're constructing these indicators to see if there is some co-location between telecommunication infrastructure and physical infrastructure. And the final, yes?
Tianfu has his hand up.
Yes.
Hi, Camilo.
Yes.
I mean, in terms of the quality of the internet, when you use the speed, the download speed, upload speed to measure the efficiency, will we be able to separate this from, like, because like correlation bit, you know, and all these nets location, maybe there are a lot more user. Instead of proxy the speed, maybe, you know, they have this location for this is not random. Maybe they have this net in location where there are a lot more users. This way you have to provide more speed, higher speed. That's one.
So I'm sorry if I didn't understand the question, like your microphone.
Yeah, because your ARPANET location, right? It could be correlated with the user location. Right now you have San Francisco, Boston, this area where it's a high density of user. Therefore, this one is located. It's not because of the random kind of location. Therefore, the speed is correlated with the user concentration. Is there a way to separate this?
What we're doing right now is, like, I'm showing you the results with download speeds, and we also have a separate set of results for upload speeds. Yeah. So we're not
if your
mixing those
capacity
together.
is fixed, right?
Yes.
if there are more user, would that
I
speed
see what you're
actually
saying.
affected? Yeah.
And let me think.
I think,
Yeah, we should. Yeah, Luis, go ahead.
I think the controlled population would deal with
Population
this.
density.
Population density would deal with this as a, in terms of the control. We could try to see some, as an outcome, some weighted average of the quality in terms of population. We would need to combine probably some census data with the FCC data, but as an outcome of the, on the left-hand side variable, that seems like a very good suggestion. We could try to do something like that.
Yeah, for sure.
Yeah.
What concern is the location may not be an exogenous, because I think they choose this location that there are a lot of endogeneity on participation.
Yeah. No, I think it's a great suggestion. And
Yeah,
it will
of
be
course.
a great.
Yeah. But it's a great suggestion. And I think that's also one of the reasons we want to use the instrument, right? Because the location of the quality of the infrastructures might be correlated with both productivity and population. So that's the reason we're using the IV. But we could choose a different outcome, which is like an amount of people that get high quality internet, let's say, like as a share of the county population. And we could try to do something like that, combining block level data with the FCC block level data too. But that's a great
Yeah, that's a really good point.
Thank you.
Okay, so
Camilo,
yes,
I
okay.
a question about whether, maybe, I'm sorry if you mentioned this, but is the ARPANET, are the ARPANET lines underground or above ground? Like I'm surprised that they're not correlated with other types of infrastructure, because I would have thought that the path that would have been chosen between two nodes is related to like local topographical conditions and ruggedness and changing in steepness and things like that, that would also make it easier to build other types of infrastructure.
Yeah, I think it depends a lot on what connection we're talking about. So actually, the historical evidence tells us that there were a couple of experiments of trying to use the existing telephone lines to expand this internet infrastructure, and they were not able because the telephone lines were very small. But at the same time, your concern is the same concern of two of the referees that handled our paper recently. And that's why we're trying to incorporate more information about the.
It wasn't me, by the way.
Are you sure, Luis, it wasn't you? Yeah, so we're trying to incorporate all that information to study more those issues. But at the moment, we don't have an answer for that, a clear answer for that. Right now, it seems it does, because we're using, well, it seems like in some places it doesn't, in some places it does, but at the same time, this is the map of the primary roads in 2019. So we're going to try to build these indicators using the road system in the 1970s, which was not as complete as this one that I'm showing you today. So,
and in that respect, one thing that could be useful, not perfect, but I know that you're including market access measures, right? So you could have market access measured with speed by car and railway, and so that in a way would take care of the other ways in which access through other types of infrastructure could be affected.
Perfect. No, that's a great suggestion. Thank you.
Camilo, just another suggestion. Maybe,
yes.
To separate the two, instead of measure the outcome as economic growth, would there be difference, let's say, because the internet kind of infrastructure may generate more creative kind of outcome compared to normal infrastructure? Is there a way to find other measures of the outcome?
Of economic growth, you mean?
Other than economic growth, maybe others kind of outcome, like more number of patents, number of joint ventures and so on.
Because this
could be more correlated with the use of internet. Yeah. So we actually have from the normal infrastructures.
I'm going to show you that we have a lot of different outcomes, and the whole different outcomes. But like, the fact is that sometimes they're not comparable, right? Sometimes they're telling us just different stories. And this we wanted to tell a story about growth and local specialization. But we're going to try to see what other outcomes that we can find that at least help us tell this story better. So in terms of the results, So first, I'm showing you the results of the effect of internet on short-run economic growth. We see, we explore 4 outcome variables. First, growth of GDP, growth of annual payroll, growth of employment, and growth of average wages. We see like a very weak effect on the growth of GDP, but still significant, and suggests that doubling internet speeds leads to around an increase of between 2 and 3.7% in the 4-year GDP growth rate. This might sound like doubling is not a sensible example to put, but it's a sensible example in the sense that I was telling you that the difference between the county in the middle of the distribution and the 75th percentile distribution is around 300%, right? So it's a really large difference, which means that doubling internet speeds is not like unrealistic scenario. And this effect is also not unrealistic if we consider the interquartile range of this distribution is around 15 percentile points. But in case you don't believe this because it's not significant, let me focus on employment, where we see a strong effect. And we see that a double internet speeds can lead to an increase of around 3 to 5 percentage points in the 4-year employment growth rate. So there are sizable effects of employment, but quite weak effects on GDP and annual payroll. And this is translated on a negative effect on the growth rate of average wage. So this doesn't mean that places with better internet have lower average wages. In fact, they have higher average wages, but are just wages that are growing at a smaller rate.
Hi, Camilo. Can you say something about how many counties out of the 3,000 actually have non-zero measure of, being close to the network? Because in the map that you showed earlier, it seems like the majority of the northern part of the country is sort of very far from these places, right? So it's like they're going to receive a 0 in terms of treatment, but you're still including them all in the regressions, right?
Yeah, so our instrument is in fact the distance to these counties to the line. So no one has a 0 here. Everyone has a positive number. And in internet, also everyone has some information regarding the internet.
I see. So the further away you'll have like a greater distance, but it's like.
Yes, exactly. You have greater distance.
Inversely correlated with internet quality.
Exactly.
Yeah. Right, thanks.
And just because we think these results are so important, we estimated a bunch of robustness checks, and these results are robust to using upload speeds, further restricting the spatial autocorrelation term, using other years of the ARPANET as our IV, including all counties in the continental US, in particular, excluding counties in the 6 metropolitan areas with a large concentration of nodes. So we say, okay, let's take out all New York, all San Francisco, all San Jose, all Boston, all DC, all Los Angeles, and the results remain. So this is not a story about cities, about large cities and how they drag the rest of the economy. It's a story about how the intermediate counties are being affected by this internet infrastructure. We also use other measures of download speeds as a measure of internet quality, and the results also hold. For the long-term economic growth, as I was telling you before, we use population growth instead of employment or GDP because it allows us to see a long-term comparison. So we estimated 2 specifications. First, a 2-stage regression where we have 10-year interval population growth as a function of internet quality instrumented by the distance to the ARPANET line. And we find this positive effect that it becomes significant in the later period. This serves as, in particular, this first period serves as a good placebo specification because we shouldn't see an effect on the 1930s and the 1960s. There was no internet at the time. In this intermediate period, we start seeing like a positive shift, but really large standard errors, which this is normal because by the late 80s, early 90s, this internet was already expanding. So we already have some other intermediate effects in the middle, but we see that in the later period, we see this positive effect. And this positive effect suggests that counties that have expanded their internet twice as much in net terms have seen population growth rates of 20 percentage points larger between 1990 and 2020, so between this 30-year interval. We also have this specification exploring right away the reduced form estimates, right? So this means having on the left-hand side these population growth rates, and on the right-hand side, the distance to the ARPANET infrastructure, and we see a similar result, right? Like null results for the early period, large standard errors for the intermediate period, but significant and more precise estimator for the later period, suggesting that counties that are farther away from the internet infrastructure have lower population growth rates. In terms of sectoral composition and structural transformation, right, we estimated 20 different equations in this case, exploring the sectoral employment share in one particular sector on the left-hand side, on internet quality in our two-stage specification on the right-hand side, and we find, this is for employment, that internet favors education, administrative services, professional services, entertainment, and management services, right? All these high skill services. And what are the sectors that are like damaging the most, negatively affecting health, retail, manufacturing, and even finance and insurance? So this was like kind of puzzling. I'm going to tell you about the story about finances, right? And we'll see that it's a lot of heterogeneity within that sector. But we see that, for example, for manufacturing, there are huge standard errors, and it's because the census data like disaggregates very well all these services. But when we talk about manufacturing, they pull all manufacturing in one single group. So this explains this manufacturing large standard errors. And similarly with health, there is a lot of heterogeneity with health that I'm going to show you in a few slides.
Can I ask a question?
You have time? Yeah. Okay.
There's a larger literature showing that consumer internet has a similar impact. And have you looked at consumer internet too?
We haven't. So we haven't, but you mean a similar impact on what? On firms and sectors in general, or
on labor market, education, and health, things like that? Yeah.
Yeah, no, we haven't explored that part of the FCC data, but we can take a look. Thank you.
No, it's fine if you want to eat into your Q&A, Tim, but there's 3 minutes left in the formal.
Okay, so I'm gonna rush with these few slides. Sorry about if I talk too fast. So we find similar results using GDP, also like high effects on high skilled services like professional services, management, information services. Now we see the financial and insurance are here in the positive side. And we also see the negative effects on, again, on retail, health, transportation, these local non-tradable services. So when we start digging into the 3-digit sector to see what are these heterogeneities, we find interesting stuff. So here we had to estimate like almost 100 regressions because there are 100 3-digit sectors. So I'm not going to show you 100 coefficients, but let me focus on 3 specific sectors. For information, we see positive effect where we should observe those positive effects in internet service providers, data processing service, information services, telecommunications. And we see 0 effects on publishing, entertainment, broadcasting. For finance, we see that the negative effect on employment is being driven by these credit intermediation related activities. This is in fact the sector that contains all those commercial banks that we see in every town in North America, that you can go to the smallest town of 500 people and you see a small bank. These are in this subsector. Similar with health, the negative effect is being driven by this ambulatory health, social assistance, all these local services that are provided by the government in every town in the US. So this stock, and when we see retail, it happens something similar. So these stocks that places with better internet see a negative effect on these local non-tradable services. On the other hand, in financial, there is a positive effect on these security, commodity contracts, and other financial investments, which contains all these high-tech finance sector that are expected to be positively affected by internet, and in healthcare, hospitals are positively affected. So as a small conclusion of this part, better internet is causing traditional banks to shrink, but is benefiting high-tech finance on all these more advanced financial products, is helping hospital activity growth, but is harming the social assistance sector, at least in relative terms. And administrative and support services are benefiting. So in general, they're benefiting high-skilled tradable services. When we explore the mechanisms, we explore two main mechanisms. First, input-output linkages. So we go through these input-output tables and try to build for each sector. How much do they rely on these ICT inputs? We rank them from 1 to 4, being 1 the sectors that benefit the most and 4 the ones that benefit the least. And we find that most of the results are being driven by those sectors that have a high reliance of ICT inputs, right? So sectors like information services, right? High-tech finance rely a lot on these inputs, and when there is a positive shock on the internet, they see this grow on this sectoral growth. We explore a second mechanism, and I can reply to all the questions in 2 minutes. We explore the mechanism of sorting of workers into ICT-related occupations. So we find that faster internet increases the number of workers in occupations that might benefit from the use of ICTs. So engineers, managers, administrative occupations, scientists, and all that stuff, right? So we see that counties with better internet have seen an increase both in shares and in logs of the number of workers in ICT-related occupations. But it has also induced migration toward these areas. So we believe this has created like this virtuous circle where these sectors that are benefiting most from these ICT inputs are growing more, are starting to demand more workers in these occupations, right? And they're growing even more and they're starting to demand more. So there is not only this increase in these sectors, but it's also inducing migration toward this area, in particular with these type of workers. And this is quite related. I didn't have time to talk about this. Is in the paper with two theories of international trade, the Rybczynski theory of the Heckscher-Ohlin model and the capital skill complementarity literature. And in fact, we see this final piece of evidence that those sectors that are benefiting the most from internet expansion tend to be those sectors that also use a higher share of ICT-driven occupations. So both of the mechanisms are actually quite related. But this has created like an unintended consequence, and I'm gonna finish with this slide, and is that counties with better internet provisions are counties where earnings inequality is increasing. So it turns out that counties with better internet provisions had seen an increase of earnings of workers with graduate professional degrees, with bachelor degrees, but have seen no effect on workers with less than a bachelor degree. So within these places, the economy is growing, but maybe the benefits are not going to all of the population, only to those high-skilled part of the population. And I'm gonna leave with this. These are the conclusions, just a summary of what I presented. For future research, well, first, we're gonna try to incorporate and evaluate all the comments you have given me. And second, we'd like to explore if these internet improvements are zero-sum or if they are a positive gain for the economy overall, and maybe what are the impacts of these internet expansions on a cross-country inequality. So we saw that within county inequality have not been great, but what about across county? And yeah, thank you for your patience. Sorry that I spent 4 minutes more, but I'm happy to take all the questions.
So thank you. And I wonder still if there is any way to make it panel data somehow.
Yeah, so, yeah, Luis, go ahead.
So I think we are a little bit limited by the FCC data. One of the things that we're trying to do now, and we're talking with one of our colleagues at the University of Richmond, is we could try to use the initial connections to ARPANET and SFNet, which we already do all the historical data on how growth increases via maybe more scientific activity. Basically, some universities start joining across time in the 60s, 70s, and 80s, both ARPANET and SFNet, and we could see how scientific activity is increasing, which is an indication of growth. Unfortunately, we're a little bit limited on the modern times by the FCC data. One of the things the project takes a little bit longer is we have to go through a lot of records by the Department of Defense on when exactly the university went and connected. to the ARPANET and NSFNet. So we have to get the NSFNet, like literally the bureaucratic documents from the National Science Foundation and the bureaucratic documents of the Department of Defense. And that would be our best way to do the panel data, but we have definitely thought about it.
Thank you.
I think Yunji has a question.
Hi, Camilo and Louis. Thanks for the really interesting presentation of the paper. I found the heterogeneity across industry result really interesting, and it must be related to some kind of, my question must be related to the mechanism behind it. So did you check the output, like GDP per worker? So I'm thinking of whether there exists productivity increases, but overall the share effect is sort of like, I was like thinking of whether the share is related to the productivity, but indirectly yes, but like output per worker might indicate better productivity part. If I miss it, then yeah.
Absolutely. Like, we haven't estimated this exact regression. I think we should. But there is some evidence that there is a productivity effect in some sectors. For example, in finance, that we see that the average effect is negative or hardly significant on employment, but on GDP is positive, right? GDP is around here. So this means like it's boosting GDP, but it's harming employment a little bit. So this has to be like some sort of productivity effect of capital. And we see some, so for instance, with manufacturing, even though the standards are so large in both specification, we see something similar, right? There is a positive GDP effect and a negative employment effect, which has to be that these workers are getting more productive or there is more high capital skill complementarity. But as of the regression as such, we haven't estimated, and we're going to try it. Thank you. Ian had a question too.
Hi.
Hi,
this is interesting stuff. I had a couple of questions. First, on your instrument, I noticed you treat your instrument as if it's straight lines between the nodes, which which the lines might be, but in practice they might not be. Do you have any sense as to whether they accurately are connected as straight lines, or if that matters?
Yeah. So actually, there is a lot of debate about that. Like, we had debated. So first, there is no actual data on the paths that the actual lines had, right? But there is also, some oh, sorry, I put my shirt down a little. So first, we don't have the data. However, that's why we also include all those geographic controls to try to account for these differences in geography that might affect the path of the lines. And third, even there are some papers studying roads. For instance, there is this paper by Banerjee, Duflo, and Kian that they show that they try to discuss that the location of railroads might be endogenous and they might be better instrumented by a straight line connecting the points. So I think, like, we don't have data, but I think that the line approach has at least in the literature has some support.
Yeah, that makes sense. That's that was kind of my instinct too. Another thing I noticed is that earlier on in your first table, you showed a negative effect on an average income per person or wage. And I was wondering if you had anything observable, maybe housing values or land values, and you could maybe put this in to allow you to think about this in more of a like Rosen Roback framework method, whether internet, you're talking about this as a productivity shifter, but there may be an amenity, some sort of a local amenity thing going on too, if there's, consumer internet and producer internet are correlated in that sense.
We haven't checked that, but I think it's also a really good question, and it sounds like almost like a whole different paper, like that you're giving us an idea, so thank you. So, but it's a great question, and I think it's something, at least with housing prices at the county level, we can find data for this. Thank you, Ian.
Thanks.
Luis?
Yeah, I was thinking about Ian's point about the straight lines, how it would work to your advantage, and maybe you should highlight that. If the first stage still survives, it could have been the other way around, but if it does, then it works for you. Then the second thing is you kind of mentioned that the implications for internet subsidies across the country. So this is more like a policy question, and I was wondering if you have thought of this new service, maybe not so new anymore, this Starlink, this wireless internet that kind of it's all satellite, so it doesn't require the. I'm assuming it's not connected. Maybe it is. Maybe it uses this type of lines, but if it doesn't, then it would be interesting to think about probably another paper, where in a counterfactual, do you either change the subsidies or do you invest in a system that is completely disconnected, but from these initial lines?
Great question. I didn't know about that. I don't know if Luis Baldomero has something
and I
to
know
say.
people who work in rural areas that have been able to get high-speed, reliable internet through that. I think it's part of one company associated with Tesla. But I know it's providing internet, and they also had provision in Ukraine during the war. So they are kind of proposing universal access internet that is coming from satellite directly, but it would be useful for you to look into that.
Yeah, no, I'll take a look. I don't know if Luis is still here, Luis Baldomero.
Yeah, I think the Starlink, it would be cool if we can get sort of like the coverage by area. We could see like the actual effects from satellite internet. One of the things about satellite internet versus cable internet that we need to be careful is the reliability. Satellite internet, as good as it is, and it's fantastic that I can go to Western Virginia in the mountains and be connected. It becomes really like the reliability depends on the weather. It's very, very dependent on the weather. And moreover, the variance of the quality of the variance of the speed actually is very sensitive to weather. And one of the things when it comes to internet to businesses is that certain types of businesses, for example, hospitals, do need very good internet above 500 megabits or even 1 gigabit, whereas the upper limit of Starlink is 150 to 200 megabits. So it would be helpful, for example, for maybe a farm owner who is in the western part of Virginia or West Virginia who wants to connect to auctions of cows. This is a thing. I didn't know this was a thing, but you can actually auction cows via the internet. But if you want to get medical services or you want to get certain services relating to credit, where you need really stable internet, satellite becomes like an issue, which means that to some extent you could say that Starlink might not be a perfect substitute of the good old cable. But it would be a great idea to see. We're going to check if Starlink coverage, like there are maps about it, because we could write a very quick paper using Starlink coverage for sure.
David, is there time for an extra question? There is one more.
Yeah, I think Vinicius has one question. That can be our last.
Okay. Hey, Camilo.
Hi, Vinicius.
Luis, good to see you. Fantastic paper. I was just wondering if you could push this idea for other measures of internet beyond quality. So like my first thought was about if you have information about prices, for example, you could look into not only the speed, the absolute speed, but also like a speed per dollar that these regions are having access to. And in addition, if you have information about, for example, the number of internet providers, you could also look into some sort of the concentration of the market and how many providers are in these areas. That could also explain could be important for these differences in speed and quality also.
Yeah, no, thanks for the comment. So regarding market concentration, we can definitely take a look at that. We have the data we need, and we can even go to a more disaggregated geographic detail. Regarding prices, the FCC data doesn't have prices. I'm sure they exist somewhere. We just need to do a little bit more digging or win some grant to be able to buy the price data, but yeah, it will be interesting to see the whole market structure about this, behind this. Thank you, Vinicius.
Okay, I think we're out of time. I think we have to leave it there. Thank you all very much. Thanks to Camilo and Luis for an excellent paper. Thanks to the audience for an excellent presentation, discussion. Thanks to Tess for hosting with me. I hope everyone can join in 2 weeks on April 12th. Chris Palmer from MIT will be presenting the last mile of monetary policy and attention reminders in the refinancing channel. That should also be an excellent paper. So look forward to hopefully seeing you all then.
No, thank you. And thank you all for the comments. They were very useful.
Yeah. Thank
Bye-bye.
you.